You guys ready?
Sure.
Take it away.
Okay. Thank you, everyone. Great to be here. So my name is Morten Thomasson. This is my esteemed colleague, Mats Hultgren. We work with the same thing with Cyber Security Advisors. And as everyone knows by now, I'm obviously the big boss. I don't know what to do about that. Either I should stop practicing my blue steel look when someone's taking pictures, or my management by fear needs some practicing. I don't know. But anyway, so we're going to talk about how to protect sensitive data here. So it's sort of a mix between information security and IT security. So we're going to talk impact assessment. We're going to talk data classification, information classification. But we're also going to talk some encryption stuff. We're not here to teach everything about how to implement encryption at rest, but we're going to talk about the strategies needed to protect sensitive data. The sort of start for this session was that, as some of you may know, we work a lot with the GDPR, and there are stuff in there that talks about encryption and terms like pseudonymization. And our customers started asking, what is this? And for our international viewers looking on this, the GDPR is going to affect you as well. If anybody working with European citizens as customers are basically going to be impacted by the GDPR. But this is not a GDPR session per se. So anybody working with lawyers after a while is going to start using this. I'll click on with the next part, please, Mats.
Yeah, so we're primarily going to talk about encryption at rest. Should we care? So even the ancient Greeks, no, I promise you not to say that, so I won't go there. Encryption is what helps our secrets remain secret. And if we look at the media these days, I think we're doing a bad job at it. There's a new breach more or less every day at the moment, it feels like. So the need for encryption is big. And according to some regulations and laws, it's essential for protecting sensitive information. But let's be honest, that encryption is just another security control. And it's the last line of defense we have when all the others fail. And we know that a lot of them will fail. As you have seen from our colleagues at Truesec, how easy it is to hack a network and hack an environment. So we need that extra layer of security by encryption. And if we look at the PCI DSS, that claims that you have to have some sort of encryption. We have internal requirements in our policies, maybe that top secret information needs to be encrypted. And we also have the legal ramifications in GDPR.
Yes, we do. We're going to come back to the GDPR and those requirements later. But one important aspect, though, is that it's obvious that it's going to be easier to move data across geographical boundaries if we encrypt it. But that being said, just to sort of identify the landscape here, we're going to talk about both primarily data at rest, but it becomes quite obvious. We're going to talk about different sort of attack scenarios and what are we really trying to protect against. And it becomes obvious that data in use will be the primarily attack vector when you're trying to defeat encryption at rest. So it's going to be a subject we're coming back to.
Yeah, GDPR Snake Oil. Have you heard the term snake oil? Silver bullets, this is what you need to do. There's actually some vendors that claim that if you encrypt your information, then you will be roughly 70% compliant with the GDPR. That's snake oil. The regulation mentions encryption 4 times, but it's always as an example of a security control that you can use to meet different requirements. But I mean, if we look at pseudonymization, that's mentioned 14 times in the regulation. So maybe that's even more important than encryption. So with that said, don't believe anyone that says that encryption is the way to handle the GDPR. It's important, but it's not the silver bullet. It's just snake oil.
To summarize that, we need to understand that basically what the GDPR is saying is that based on the risk of processing and the risk to the individuals, you have to take appropriate security measures. So there's not a requirement per se. It all depends on the risk to the individual, and we're going to talk a bit about how we define that risk as such.
Yeah, and how do we start then? Well, as always, we need to identify stuff. So let's start with information classification, and let's do our business impact analysis so we can determine if our systems are sensitive or if they are critical, because that needs to come into context when you start classifying the information and what systems they reside on. So if we move over to the classification matrix.
Yeah, so this is a typical information classification. Just a question to you guys. How many here, I don't have Richard's fancy tools, but just a hand up. How many here do information classification? Okay, it's not really as many as I would hope. Why is this important? Well, the thing is that if typically, if we don't have information classified, systems classified, IT is going to have to guess how sensitive information in a specific system is. The reason why I wanted to show you this is trying to identify when do we need to start thinking about encryption. So let's say that we would set a requirement that any information classified as confidential need to be encrypted at rest. So what would that entail? I think this is a quite true classification of data. So we would say that, okay, PII of employees, customers would need to be encrypted. We would say that incident reports would need to be encrypted. We would say that financial records, or you see prior consultation with the supervisory authority, that would be if the risk is so high after you have implemented all your security controls that you still feel a bit unsure, you would have to send that to the supervisory authority and have a dialogue with them. So that information could entail all of your security controls. It could be network diagrams, all of that stuff. So it can be fairly sensitive stuff. So you would probably want to have that encrypted, right? But the problem is that if you say this for all that information, you're going to encrypt a lot. And if we do it for only strictly confidential, then suddenly we would have a definition sort of saying that, okay, so we don't need to encrypt our customer data. So it becomes sort of a binary decision that I don't think fits very well at all. So if we continue with that, what we want to have is, so we're giving you sort of a process here on how to think about the protection of data, right? So this is a security control matrix where you want to map the different security controls to a specific classification. So for example, in this case, we're saying that we want to do file access monitoring for critical information. So what would be the effect if the confidentiality would be compromised? So if that would be critical, we want to use multi-factor authentication, right? But we want to have encryption at rest as well here. And I think that somewhere where I would want to land in a process like this would be that we would say that, okay, so if the reason would be, or the consequence would be catastrophic, you want to do some sort of more risk analysis. And if that risk analysis shows that there is a high risk, then you want to apply that security control. And this is a process that would obviously work on more than encryption at rest. It's a process that would work for any sort of cost-driving measure. So you could basically use your security control matrix to define a baseline. So this is what we always want to do for this particular classification, and this is the stuff that we need to do some more digging into.
And the scope of the processing is very important as well.
Yeah, exactly. And the scope of the processing is, we're going to come into that. There's a difference in having sort of one highly confidential document on a file server, for example, or any server, compared to 1 million. But if you do your classification and say that anything here must be encrypted at rest, no matter what, then that document would become sort of toxic data. It will drive cost for a specific server, right? So the scope of processing becomes important. So we talk about a data protection impact analysis, data processing impact analysis. It's an example of a risk-based method. In this case, it's specific in relation to the GDPR. So we're expected to do this according to the regulation if there is a high risk. And obviously it becomes then a definition issue of what entails high risk processing. And this is a very important topic, and I think that all of the companies in Europe or anybody doing business with European citizens is going to have to sort of define.
Yeah, it might be good to mention that the difference between DPIA and the risk analysis is that the risk analysis, you're going to do that for your company and how a certain event might impact your company. The DPIA is always focused on the registered person. So how will that affect exactly you? What will happen to you in your private life if this information leaks? How will that affect you? So that's one of the big differences here that it's good to bear in mind.
So what is then high risk? How do we define that? There's actually a quite good document on this produced by the European Data Supervisory Authority that says that there are a bunch of types of processing that you can do, and if 2 or more of those sort of fits what you're doing, then you should do a more thorough impact analysis. So what we're talking about here is, for example, if you do evaluation or profiling, it could be you have your yearly review with an employee saying, you know, you could do this better, or this is very good, and so on. That sort of evaluation, right? For the same reason, profiling could be something connected to your financial records or what you're actually doing, your patterns of what you shop and when you do and so on. You can look on systematic monitoring. I think it's interesting because I think many, especially here in a security session, right? So systematic monitoring would be, let's say we implement some sort of CM system where we collect the logs or we want to do traffic analysis of what our employees are doing in the network and stuff. Typical systematic monitoring. So sensitive data in this context, I think, is interesting because the GDPR says that sensitive data is typically which union you're in, or if you have any sort of your health data, stuff like that. That's sensitive data. But in this context, it's more. It could be traffic patterns, something that your operator stores on your IP traffic, stuff like that. So, or large-scale processing. So what's that? So it's sort of a combination of how big data sets there are. I mean, is there a huge data blob regarding everything you do in your life? That's sort of large-scale processing. Or it could be also how long you store the data. Is it a month or is it 10 years? So it's sort of a aggregated value of large-scale processing. So, and vulnerable data subjects, that could be an employer situation. It could be patient, children, elderly. And if you start looking at this, so if you have systematic monitoring of your employees, that's a combination of sort of vulnerable data subject and systematic monitoring, and that hits 2, and therefore it's high-risk processing. Okay, so you see how you would work with that. And I think it's obvious that we're going to see a lot of cases where we sort of hit that it's a high-risk processing. So what do you do? So if you, let's say you land in, you realize that, okay, so we have high-risk processing. What do we do then? Does that mean that, okay, so we should just encrypt the shit out of it? Or does it mean that, you know, we have to do something more? And this is sort of an example of how we could do that. So you look at, okay, so evaluation of scoring, including profiling, do we do that stuff? How large are the data sets? Do we move data to several countries and stuff like that? And based on that, you can do a sort of decision matrix and land in that, okay, so there's a fairly high risk here. And then you decide that, okay, so if we land here that we have a very severe impact with a high likelihood of happening, then, okay, we need to sort of use encryption at rest. So I think that this is sort of a method that we're going to see being implemented when it comes to not only encryption at rest, but for different protection technologies.
Yeah, you're going to have to combine a lot of different security controls to simply mitigate all these risks.
So what we're talking about here, so the process that we recommend is basically that classify your data first, move that into a security control matrix, that this is our base set, and this is our more thorough security features or controls we need to do. Do we have high risk? Identify that, and if you do a detailed risk analysis and land on whether or not you should do encryption at rest, for example. And if you can show that you have done your sort of due process, it will, of course, help you later on if you would have an incident and you would have some supervisor authority asking you for, you know, have you done your risk analysis? What mitigating technical controls have you implemented and so on? And you can show that, you know, here's our due process.
I mean, that has to be based on different scenarios. What we're going to protect against, I'm suggesting.
Yeah.
So today we're going to go over these scenarios. We're not going to go deep diving into the technology, rather paint you a picture here about what's possible and not. So we're going to look at different attacks in different contexts, backup operators, server admins, administrators of virtualization platforms, standard users, service accounts, that kind of thing.
Yeah, exactly. And the reason why we're doing this is, of course, that what we see a lot is sort of back to the GDPR Snake Oil that Mats was talking about. So we're saying that, okay, we should encrypt at rest, and then we're good to go, then we are GDPR or any other regulatory demand compliant. But what are the actual scenarios that we want to protect against? Because there's a huge difference on whether or not you want to protect against accidental spread of an Excel sheet, or if you're really worried about having your sort of fabric administrator being the evil admin. You can't apply the same protection mechanisms for those kind of scenarios. So before you start just making a decision company-wise that we need to encrypt data at rest, you have to sort of think about the different scenarios that you want to try to protect against. And I think that this is really important, because otherwise it's just going to be a cost driver without any actual benefit.
Yes, let's look at the first scenario then. And like Richard pointed out earlier when he talked about Verizon, I mean, we talk about inside threats, internal threat agents and stuff like that. But I mean, it doesn't have to be an evil admin. It might just be a sloppy admin who forgot his password or got hacked. I mean, we do know, we always preach that start protecting your high credentials, high-value credentials. Yeah. And still, that's why people get hacked 9 out of 10 times, something like that. So Let's say that an attacker gets a hold of an account with backup privileges, a backup admin. What can we do then?
So one example is that Richard was talking about. We can do transparent data encryption. That basically means that we encrypt the SQL server and, for that matter, Azure SQL data files. And we're using a certificate here for the encryption. And typically, if you do this on a local SQL, that certificate is stored in the machine. What you have to know then is that, of course, the data will appear in clear text in the memory of the server. But I won't be able to sort of copy the database out. So typically, if I would do an SQL backup, that backup will be encrypted, and you can feel sort of you covered the scenario with the backup operator having access to the data. But then, of course, you have to think about back again to the scenario. So you're sort of worried about the evil admin or evil backup operator. But then you have to think about, so, okay, so how was this done? It's the certificate stored in the local certificate store. So then you would need to separate the actual SQL backup from the server backup. Because if you have access to both, you have access to the keys, and then you can sort of decrypt the database. So that being said, if we...
Yeah, number 2.
Yeah.
Let's look at what can we do then if someone gets a hold of local administrative privileges. I mean, this is a scenario where we see that you can dump a database out, for instance, and steal the encryption keys. So what can we do to mitigate this?
Yeah, and this is sort of the... What we have to think about here is that we must choose then an encryption scheme that does not expose the private keys in memory. Because if you have local admin on the server, you have access to the memory, you could do a memory dump, and then you have the encryption keys, right? I mean, we're not taking any sort of consideration to the complexity of the attack here. We're just saying that you have access to the memory. So if we take then, Richard touched this as well, if we talk about application level encryption, an example of this would be then always encrypted. This is also, I mean, if you read some documentation on this, it's called sort of client-side encryption. What we're talking about is basically that we move the encryption, decryption to the application side. We are not doing it on the SQL as such. The advantage is then, in this case, the data is actually encrypted both at rest, in use in memory, and also in transit. So it sort of covers all three, but just between the application and the database, right? But this is sort of Microsoft implementation of looking on specific types of data, like social security number or stuff like that, some credit card number or whatever. But the difference is that the keys are stored client-side, different from transparent data encryption. And neither clear text nor encryption keys are available to the SQL server admin. So in this case, if you would have admin access on the database level or the server where the database runs, it's protected still. But this obviously requires some thought on role separation, because once again, like we discussed this internally, and our coding guy said that, well, in 9 times out of 10, the SQL admin has local admin on the application server as well. So, okay, so back once again, what are your scenario? What are you actually trying to protect against? So then you have to combine role separation, so different admins for different type of servers, right? Make sense?
Separations of duties.
Yeah.
If you work with SQL, you don't work with Windows Server.
Yeah.
Point.
But backups, both database and server, can of course be stored together because the encryption happens in the application.
Yeah. And then we have the virtualization platform. I mean, this is one of those interesting ones if you're either in a outsourcing scenario, a hosting scenario of some kind, or if you just don't trust your guys in black t-shirts. So there's actually a very interesting reading here about the Oakland that actually became, we're going to talk about it later, but look at that link, it's awesome. So what can a virtualization platform administrator do then? Well, he can copy off all the images and all the disks and everything and just attack them offline.
So one prerequisite that if we think about it, then is that the admin mustn't have access to neither memory nor disks of the different servers. So in this case, if we think back on the scenario, now we're having, so if we would have an application server, it would do application side, client-side encryption, like always encrypt, but the virtualization admin has access to both in that context. That sort of defeats the purpose, right? So we have to add something else. We need to protect memory, stuff like that.
Yeah, now we got shielded VMs in Windows Server 2016. It requires Gen 2 of the virtual machines, but you get a lot of fun stuff from that. You get the possibility to cut off the memory so that admins can't access the keys that store there. You got the encrypted disks. You got full support for encryption of the migration. You have virtual TPMs to seal all the keys. And you get a host at a station of health. So that I can simply say that this is my image, this is how it looks like. I can put a checksum on it. And if that changes, the host isn't healthy anymore. So for instance, let's say I have 3 servers hosting the virtualization platform. And my guarded VM, the server that resides on dies, so I have to move it over to another server. But the other server isn't compliant, then it can't move there because it's guarded. So if we look back at how this changes things, it's like before we had a physical machine that was constrained to who actually got real access to it. So you only had the server admin. But then we started with virtualization, and all of a sudden everyone had access to the machine. Didn't matter what role they had had access. But now with shielded virtual machines, we can make sure that it's just a virtual machine that's meant to be managed. So it's a very good scenario, for instance, if you have a hosted environment or stuff like that. You can make sure that the hosting provider can't do anything in there if you want to keep it from them. And of course, this is like a silver bullet for compliance. So Microsoft just draw this up, how it occurs to the ISO, the PCI DSS, NIST 853. So, good stuff.
And if we continue, this is something new. Azure Confidential Computing, I think Microsoft released it in September. This is sort of tries to cover the problem that we've been discussing, like data in use. So that's its purpose. So it's sort of like shielded VM in Azure. Data encrypted in use, and it's using trusted execution environment or enclave. So it's the same technology that is used in Microsoft blockchain. And this is something you can sort of try out today. I think that what's covered today is virtual secure mode, so it's the sort of same technology. But I think that this is interesting because here we start to get the combination of data at rest and protection of data in use, and that's sort of where we want to come, right?
Yeah, we're getting closer to this if we listen to Richard when we started looking at platform as a service instead of infrastructure as a service. This is where you need to go. Yeah, number 4 scenario then, SQL injection. I mean, this is what happens when everything is working as intended, except for one thing. You got vulnerabilities in your code. So let's look at that scenario. What can we do for that? Can we encrypt against that?
Yeah, and I mean, it's not only SQL injection, but we're talking about sort of any compromise of a service account, for example. Or in that sense, it could actually be the compromise of a user account.
Yeah. The whole point is that that account is meant to read the data. So you can't really encrypt it from it. There is no point in the service at all. So we have to use other security controls here. For instance, we need to go with role-based access, separation of duties, these kinds of things. It's really the thing that's built to do it. Data minimization. Make sure that you don't have more data in there than you absolutely have to. And make sure that you verify all your code. Do code checks, do pen testing, do fuzzing, do all of these things to make sure that that can't happen, or at least not happen easily.
Sort of precluded the conclusion there, but I think that what we want to say here is that you need to think about the different scenarios that you're trying to protect against, and then go all the way. I mean, it's really no use saying that, you know, we must protect against the evil admin, and then you implement sort of transparent data encryption. I think that that's sort of compliance cheating, you know, green tick in the box. So you need to think about the different scenarios. And as Mats was saying, we want to run the application to separate the servers from the database, role separation. We want to minimize the service account access to data. Also, data minimization, if you think about GDPR, is not only minimize what access the user would have to data, but you could also work with stuff like data masking and those types of access to data. So really think about how we expose the data to the users. So any compromise on a user account would sort of be minimized. That sort of brings us up to the next part of this. When we talk about GDPR, a lot of customers have started to ask us, so what about pseudonymization? What is that? Because it's a lot of pseudonymization in the GDPR. So what does that mean? And we talk about data minimization as a concept. So what the GDPR says is that taking into account the risks for rights and freedoms of natural persons, the controller shall implement appropriate technical and organizational measures such as pseudonymization. So here we come back to risk once again. So high risk, probably more need to implement pseudonymization or encryption or and such. And when we talk about pseudonymization and data minimization, we tend to discuss different topics. So it's tokenization, it's format preserving encryption and data masking, and we're going to go into what those mean and work. So pseudonymization it's a difficult topic to explain, but based on the description here, it says that, okay, the concept of substituting identifiable fields in a database with a pseudonym. So we're working with pseudonyms.
Yeah, and the big point being that if you anonymize something, you can't re-identify it. But with pseudonymization, re-identification is allowed. It's just at different degrees of how hard is it. Yeah.
So just to explain this in basic terms, we have a user who somehow enters personal information in an application. Tokenization, pseudonymization happens. So in this case, we have some type of vault solution where we map the clear text data to a token, and the pseudonym, in this case, the token, lands in the actual application database. So this is an example in its easiest form of pseudonymization. And this is then something that you have to think about in the GDPR. High risk, do we need to do this?
But this is more, it's a bit more like an architectural structure. I mean, of course, if you talk about tokenization, you have products, definitely. But this, on this level, is a lot more, how do we design our applications? How do we have our data flows? What do we separate and what don't we, etc.?
Yeah, because basically the token in that case could just be a random number in a database that works as the identifier as such. So we could just separate the different databases and have something that binds them together and have very strict control, and that would be a sort of pseudonymization in that case.
So I'm guessing, I mean, you might need to have a discussion with your DPO and your developers.
Yeah. Yeah, that's a fair point. So if we talk about tokenization, so this is I would say, the most common example of pseudonymization. Typically, something that you would do if you need to comply with PCI DSS. PCI DSS basically says that if it's tokenized, you don't need to do an audit on that specific system. So if your data would run through 50 servers, you would need to do an audit on all 50. If it's tokenized on 47 of those, you need to do an audit on 3. So there's a significant cost benefit, of course, when you do that. So it's a non-mathematical reversible process where you just use randomized numbers basically to replace sensitive data. That's tokenization in its simplest form. We can use it to data mask. So we can show just parts of a token, for example, just to show the last 4 digits of a Swedish person number or a credit card or whatever. It's not that well suited, though, to unstructured data, such as binary files, images, large text documents, and so on. So there we need to look at other types of solutions. If we go into that's sort of the next part. So something that we've started to see a lot is format-preserving encryption. And the difference here is that this is... Oh, I'm sorry.
No, this is the example first, man. Sorry,
yeah, the example of tokenization. So if we look here on the first field that we marked here in red, this is then your sort of protected data, your tokenized data. Over here, we have used tokenization for data masking. And in the bottom part, you can see that this is just the tokenized data. It doesn't say Dan Clark here. So this would be an example where we use role-based access to not give access to types of data. So it's a combination of how we would use tokenization for this.
So in this case, the authorized role just sees name, social security number. The rest is in some, confused.
Yeah, exactly. So then coming up to format-preserving encryption. So as I was saying here, it retains the format of the data, but it's true encryption. So there's a difference here. We just don't use randomized numbers here. We're talking about true encryption. But we retain the format. So, for example, it could be that you have in a Word document or a text document, you would actually retain the spaces between words. You could keep hyphens or an @ sign, stuff like that, which means that your applications won't break when you implement this. Another aspect is that your data format or data size won't change. So here you can see an example of a credit card number encrypted with AS128. CBC, it becomes a very large field. So obviously this will sort of explode your database, which might become a problem if you have sort of legacy application, stuff like that. You don't want to change, of course you don't need to change your field length. So one obvious advantage to format preserving encryption is that you don't need to change your schema in a database, for example. It's well suited for unstructured data, and we can also use data masking here, as with tokenization. So it's what we're seeing if we're looking on the different, and it's important to know these because if you start looking at encryption technologies, you're going to see a lot of talk about we're running format preserving encryption, and that's not tokenization. And you start thinking about, okay, so what are we talking about here? What's the differences? What's pseudonymization compared to tokenization? And we're sort of hoping that you will leave here today knowing the differences, making it easy to evaluate different products and stuff like that. That leads us into existing applications, and that's something that always comes up, like how do we... Because it's one thing to create new applications, then you sort of start from scratch and you can do all of this. But what do you do with your existing applications? Not a really easy answer, but as I was saying, format preserving encryption is one thing because you have fairly low impact to your databases. We can use tokenization to retain the format. one interesting thing we've seen is to use sort of encryption gateways. And this means that you stick something in between your application and your database, and it will sort of unpack the data, look at it, and encrypt it if it finds something. So you work with regular expressions, stuff like that, and then sort of encrypt the data on the fly. And I think that's, and then of course you would combine that with tokenization or format preserving encryption to have as low impact as possible to your database. So I think that's somewhere there we're going to land if we want to implement this on sort of legacy applications. And of course the best strategy might sometimes be to just rewrite the application. Right?
Yeah, you might actually don't have a choice in certain matters. And then bring in your data protection officer, your developers in a room, and some other security guys. And yeah, let's hope they can build something that works.
Yeah. So, with that being said.
Yeah, let's look at what happens then when we outsource things. Okay, let's go through the first point. We always talk about this, but it's still a problem, so let's keep on doing it. Retain working knowledge. If you outsource something, doesn't matter if it's your entire environment or if it's just one application or the management of it, you still need to retain knowledge about how it works and why, because otherwise you can't govern the supplier. It's fairly simple.
Yeah. A typical problem that we see here is organizations that outsource their development, but they're doing the development in silos. So they have silo equal application 1, and then the next silo is application 2 and 3 and 4. And then they're all working with different sort of identity schemes. So one application is running NTLM, the next one is using Kerberos, and then one lucky application is using OAuth, right? Or OpenID. What you want to do is, of course, identify an architectural board and say that this is how we're going to do, this is how we're going to work with encryption. That's a very, very important point, I think.
Yeah, and I mean also then work with the suppliers so that you land a common baseline between you, so you understand the requirements going both ways.
Yeah.
Otherwise, you're just going to miss the target anyhow. And when you put that into an agreement, well, then you're stuck with it for 3 to 5 years or something like that. And then you have that to wrestle with. We like to talk about due diligence through requirements and due care through governance. And like we said, you have to, the 2 points before actually comes back to that. I mean, you do your due diligence with your supplier as well, so that you put up your requirements so you know what's required of them and of you. And then you do due care through governance, and you have to have a working knowledge to be able to do that. Otherwise, how are you going to make sure that they actually deliver on what they say they do? Right? And of course, when it comes to cryptological management, don't underestimate the management overhead here. I mean, it's a lot of time and cost in that. Yeah,
and sort of back to the different scenarios we're talking about and what you want to protect against. I don't know how many, hands up, how many here have been working with sort of key ceremonies in PKI? Do we have? Yeah, we have one. A couple there. One more. Okay, so those who've been working with PKI sort of on that level knows that the actual key management and the secret management can be quite an administrative overhead. You want to keep secrets locked. You have like a key separated into 3 different parts, and you have 2 persons for every part, and you have to have a safe where those secrets are kept, and then people start moving around, and suddenly no one knows where the safes are. I've actually had that. For PKI, I've had customers who go like, you know, we're going to have a key ceremony, but we lost the safe. You don't want to end up there. The management overhead in cryptological solutions can be quite hard. Interesting thing, for example, if you run transparent data encryption and you just run it as a service, basically you go into Azure and you sort of hit the checkbox, the click, and you're done. The good part there is that Microsoft handles all of the key rotations. And they typically do this around between 75 to 90 days. And then the key is rotated. So, good stuff. If you move that to manage your own key in Key Vault instead, you rotate the key, which means that you have to have a totally different management for keys. And of course, if you would lose it, you have to take care of all of the keys, because if you want to restore backups from beforehand, you want to have the key for that. So back again, the key management, of course, becomes extremely, extremely important when you work with this.
One thing that's important with supplier relationships, we see this a lot. When you take in a supplier, you put a level of security up here with requirements, okay? You put a lot of requirements in there saying, this is what you have to deliver to us. You have to do this and this and this and this. But if you don't use a supplier, you will have to do that yourself, don't you? So how many in here have the same strict requirements on your own personnel as you have on your outsourcing or hosting or whatever suppliers? Hand up. Okay, not one single hand in there. So you have to remember that. The requirements that you put down is the same that goes back into your organization as well. So if you don't outsource it, you will have to deliver on those requirements.
Yeah. And I think that's one of the, I think, negative sides on, we had a big incident here with the Swedish Transportstyrelsen, and the result was that our government started talking about that we shouldn't outsource sensitive information. So back to our classification, I think there's a difference between, let's say, a sensitive salary file and the secrets of the national secrets of Sweden, right? So when you start talking about that you shouldn't source sensitive data, I think we're sort of doing a lot of people at this disservice. So classification, once again, becomes very important. So perhaps you would retain the national secrets somewhere, but the rest of the data could probably be outsourced.
Yeah, as well as cloud.
Yeah. So if we talk about a bit of takeaways here for this session, is that the classification models should, of course, take the scope of processing into account, as well as requirements to store sensitive data in any approved system. So I think that that's a point seldom made. We had a colleague that actually said that, you know, if you're handling highly sensitive data in your office files, that means that you're missing a system. By that he meant that, you know, if you have your most highly sensitive data, perhaps that should actually be managed in a, for that purpose, managed system. And that's, I think, an important requirement that we need to set up when we work with our classifications. The next thing is that establish a process for data protection, impact analysis, risk model, security control matrix, so you can easily define that this is the specifics that we want to implement for this type of data. And then also find a process that should trigger, or the risk that should trigger more impact analysis, or and
talk
then,
with lawyers.
Yeah, yeah.
That's an important one.
And then sort of identify the threat scenarios, and that's the key takeaway we want to bring with you here, that if you're sort of worried about the evil admin, then think it through all the way, because that's probably going to mean that you're going to do transparent data encryption together with Always Encrypt, if those are the technologies that you're looking at, because they complement each other. And you're probably going to want to implement shielded VMs as well. And you should prepare to take that. Once again, encryption should be seen as a compensatory security control. I think that's something that we realized early on, is that it's not always necessary if the data is sensitive. For example, if you have a system with 2 administrators. Those are your most trusted people in the organization. You've known them for 15 years, and those are the only guys who can access it. It's offline. What's the need for encryption? I don't think there's any need at all, perhaps. The next thing here is that encryption pseudonymization is not a substitute for defense in depth. It's a part of it, so we need good application design and coding practices. Emil was talking about that yesterday, that do static analysis of your data, or of your application. And then, for example, segmentation of your network. So in case that someone would access a system, the network is segmented, it becomes a lot harder to take over such an environment. You want to do role separation, you want to do data minimization. So in that sense, a combination of data masking, you want to do, for example, geographical segmentation. So if you have employees working with customers, perhaps only the people working with the southern regions of Sweden would have access to that type of data. That's a typical data minimization technology.
Yeah, but I mean, also look at data minimization out of the aspect of you don't have to protect stuff you don't have, right? So maybe we shouldn't collect all the information we possibly could get on a person. Let's make sure we only collect the information we really need. So let's keep it at a minimum. It's easier to protect. It's more clear. We go through all our data flows. We know what information we get in and where we get it. And then we can easily classify it and make sure we have a good security control for it.
Yeah. So keep calm and do cybersecurity. We're having a Tech Days pre-conf at Microsoft doing the cybersecurity and GDPR. So we're going to look at sort of everything Microsoft and how it fits together with the GDPR, what you can and obviously can't do.
Yeah, and together with Marcus and Assign as well.
Yeah. We're going to do the Tech Days. We're going to talk about cybersecurity and more on an information security perspective. And then we're going to have a Tech Days session together with Jacob here. Is going to talk about OMS security. I think that's all for us. Thank you.